So we'll be using our Cartesian. As we understand, our Cartesian represents a revolution. And under this revolution, if we start from 0, this will count for 90 degrees. From here is 91 to 180 degrees. And then here is 181 to 270 degrees. And here is 271 to 360 degrees, which forms a full revolution. So, this cyclic revolution is what we use to place our formulas. First of all, we remember that we have 3 trigonometric identities. As the name applies, tri means study of shape. Gono, with shapes with 3 sides, 3 angles, 3 identities, 3 reciprocals by extension. So this is what we are going to go through. As we did in grade 10, we know that we have the 3 identities, which is the sine, the cosine, and the tangents. Sine, cosine, and the tangent, which is sine, cos, and tan for shortcuts. So we are going to use 3 of them to build our base. This is like the foundation of everything we are going to do on the reduction formula. First of all, we label our thing. We use the acronym, which is CAST. CAST is the acronym we use for our Cartesian. This CAST is, if that will make you happy, I'll use this acronym. All silly teachers complain. You can use whichever acronym that you can remember, but this will help you to remember the quadrants you are going to deal with. So in the first quadrant we have A, and in the second quadrant we have S, and third quadrant, and then fourth quadrant we have C. What do they actually mean? The A here means all. It means in the first quadrant, all the 3 trigonometric identities will have a positive value. That means sine will have positive, cos will have positive, and then tan will have positive. On the second quadrant, the S here means that sine will be positive. The only one represented is the one that will take the positive value or the positive sign for each quadrant. Sine will be positive, others will be negative. Cos and tan will be negative, so whenever you encounter anything that is tan within this quadrant, it will be negative. Here, tan will be positive, cos will be negative, and sine will also be negative. In the last quadrant, which is the fourth quadrant, cos of any angle will be positive, sine will be negative, and tan will be negative. Then how do we use this to solve problem? Reduction formula is when we have very large angles that we want to reduce so that it will be for easy simplification of trigonometric expressions. Now, we may have large angles that are above 180, 160, 180, 300, 500, 1,000, but we also consider the revolution of 360. As we progress, we'll take examples that will portray what we are actually talking about here. So in the first quadrant, we say that every angle that is inside here should be less than 90 degrees. That means any angle we are going to encounter here must be 90 minus theta, where theta is an acute angle. Please remember, it is very important that you understand that the theta we are using for this must always be an acute angle. That means it must always be an angle less than 90 degrees. So any angle that falls here must be less than 90. So 90 minus that angle, that's what will fall in the first quadrant. For the second quadrant, any angle that falls there can be greater than 90. That means it can also be 90 minus plus theta. That means greater than 90. Or, since we have 180, it can be 180 minus theta. So here we are looking at angles that are greater than 90 degrees, but less than 180 degrees. Remember, theta must always be acute. In the third quadrant, we are looking at 180 plus theta. It must be greater than 90 degrees. Greater than 180 degrees, but less than 270 270. So it can also be 270 minus theta. Remember that theta must be an acute angle. So if any angle falls in the fourth quadrant, it can be 270 plus theta. Greater than 270 goes into the next quadrant, or 360 minus theta. So these are what we use to figure out the angles depending on which quadrants they fall in. So with this we can arrive at the value for every given trigonometric expression and what we can actually reduce it to for easy simplification. We'll take examples as we go on, but let's write out everything. It means that when I'm working on the first quadrant, if I get an angle of sine of, okay, before I go on, let's talk about what we call the cofunctions. The cofunctions for reduction formula are the functions that involve 90 degrees and 270 degrees. So angles that involve 90 degrees and 270 degrees, we treat them separately. The cofunction means they produce a value for what the other trigonometric identity had. That means the cofunction of sine can become cos. The cofunction of tan can become what we call cot, which is a reciprocal of tan. So they produce what they have on the other side. So for cofunctions, we'll explain later more details when we go into solving the problems proper. But for now, let's give the foundation. Now for sine of 90 minus theta, since it is a cofunction and they are all positive, it takes the sign of the original. The cofunction will become cos of theta. Let's take an example. Sine of 90 minus 60. We say it becomes the cofunction. So it becomes cos of 60 degrees. If we look at this, if we simplify, the sine of 90 minus 60 is 30 degrees, and we say that it is equivalent to cos of 60. If you check properly, sine of 30 is a half, and cos of 60 is also a half, so it's equivalent. So reduction formula helps us to get a reduced version of what we are dealing with instead of dealing with bigger values. So cofunction of sine of 90 minus theta is cos of theta. For cos of 90 minus theta, the cofunction becomes sine of theta because cos is positive, sine will be positive. And then tan of 90 minus theta becomes cos of theta. So these are the cofunctions for the first quadrant. Let's look at the cofunctions for the second quadrant. I'll write it up here. Now for the second quadrant, if I have 90, I'm using 90 still on cofunctions, then if I have sine of 90 plus theta, I will check this sign, whether it is going to be plus or minus for sine on that quadrant. 90 plus theta is now on the second quadrant. That means any value greater than 90. It is still a cofunction, but sine is positive, so cos will be also positive. It gives us cos of theta. If I have cos of 90 plus theta, now if we look at this section, 90 plus theta, cos is negative on this quadrant. So your answer will also be the sine of the original. It is also a cofunction of sine, but sine will be negative sine theta because cos, the original man, has a negative value coming into the next quadrant. Likewise, if we look at tan of 90 plus theta, it becomes negative of cos theta because tan is negative on the other quadrant. Now, lastly, let's look at the 270s. We also have 270. So if we have sine of 270 plus theta, now on this quadrant, sine is negative. So the cofunction will also be negative. If we look at cos of 270 plus theta, we are looking at plus is looking at the last quadrant. Cos is positive here, so the cofunction will also be positive. If we are looking at tan of 270 plus theta, sine tan, the cofunction tan is negative here, cofunction will be negative, cos theta. Now let's look at the third quadrant. If we have sine of 270 minus theta, if we check here, sine is negative here. So the cofunction will also be a negative of cos theta. If we are looking at cos of 270 minus theta, this is on the third quadrant. And on the third quadrant, cos is also negative. So the cofunction will also be negative sine theta. And then the last one is tan of 270 minus theta. If we check very well, tan is the product of this quadrant with a positive. So whatever is cofunction will be, will also have a positive, which is cos theta. So these are the cofunctions that we have. Remember, we use cofunctions for all 90 and 270 degree angles. Now, quickly, before we go on and take our examples, let's quickly go through the other angles that are not 90 degrees and 70 degrees. Now, what do we have left? We have 180 and 360. So let's look at one sine of 180 minus theta is on the second quadrant. Sine is positive, it is not a cofunction, so it returns its value. If we want to check this to be sure, if we have sine of 180 minus 30 degrees, we say that sine, this is sine of 30 degrees by the formula, by the given formula. And we can check to verify if this is true. This is sine of 150 degrees, and we say that it is equivalent of sine of 30 degrees. If you have your calculator and punch and check, you will see that sine of 150 degrees is equivalent to sine of 30 degrees. That is the essence of working with reduction formula. When you have a very high values, you can easily simplify them, that's reduce them, and then get the actual equivalent from these formulas. Now, let's go on. Now we have cos of 180 minus theta. 180 minus theta is here, and cos is negative. So we must take that into consideration. It returns its value, is not a cofunction, but it will have a negative. The same applies to tan of 180 minus theta. It will have negative tan theta. And then we go to sine of 180 plus theta, which will be on the third quadrant. Sine is negative, it returns a negative. Cos of 180 plus theta will return a negative cos, because cos is negative on the third quadrant. Tan of 180 plus theta will return positive tan theta, because it is on this quadrant and tan is positive. And then lastly, we'll look at the 360s. We look at the 360s, so we have sine of 360 minus theta, which will give us sine of theta. This is sine, fourth quadrant. Be careful, fourth quadrant, sine is negative. So we will have negative sine of theta. Then we have cos of 360 minus theta. This case, cos is equal to that fourth quadrant. 360 minus theta is here, so it will give us a positive cos theta. And lastly, tan of 360 minus theta will give us negative tan theta, because tan is negative on this quadrant. We will progress and we will take examples. This is just forming the foundation. If we understand all this, we can easily solve any problem associated with reduction formula without any problem. All we need to do is to understand how this stuff works, and then we can break down any angle to components of this and use it to solve. I'll see you in the next video. Please remember to share and remember remember to share with your friends. Bye for now.